Hello everyone, today in this video we are going to talk about networks and we'll solve one question on network. So network is nothing but a complex system of conductor. As you can see in the diagram, there are many resistors and cell combined together, and this network problem cannot be solved using Ohm's law. So we have to have different approach to solve this. So a junction is a point in a network where several conductors meet, and a loop is a closed path in a network for current to flow. So out here, see in the diagram, you can see D, E, F, C. D is a closed path for current to flow, so it is one loop. So C, F, A, B, C is also a closed loop for current to flow, so this is another loop. And even you can take D, E, A, B, D, so this is a big loop out here. So in this network also you can see this is a loop and this is another loop, and out here also if you start from here you'll come back to the same position back. So this is also a closed path for current and it's a loop. So this is also a loop, this is also a loop. So you can combine two loops to make a big loop. So see, if you start from here you will come back out here. So even if you add several loops together you'll get a big loop out here. You can see this is also a loop. So in order to solve the problems on network, we cannot use Ohm's law, so we use Kirchhoff's rule, and it has got two rules. One is junction rule, another is loop rule. So this is first rule, and this is called junction rule or Kirchhoff's current law, KCL. And this law says that in a junction the algebraic sum of all the current is 0, meaning if you add all the current taking the sign, then you'll get 0 current at the junction. Or in simple words you can say the sum of current entering the junction is equal to sum of current leaving the junction. So as you can see out here, this is a junction. So in order to use this rule we have to use sign convention, meaning direction to the current. So we consider current going towards the junction is positive and the current going away from the junction is negative. So let's use the first definition, that is algebraic sum of current is 0. So I1 is I2 is entering, so they are positive, and I3 and I4 are leaving, so they are negative. If you add them you will get 0. So this is rule number 1. And in the second definition you can say the current entering, the sum of current entering is equal to sum of current leaving. So I1 in I2 is entering and I3 and I4 is leaving, so their sum is equal. Now let us solve one question on junction rule. So as you can see in the diagram, 2 ampere and 3 ampere is entering the loop and 4 ampere is leaving the loop. So you have to find the current in this branch. So I'll assume that current is entering through this loop, I current. So I can use the rule 2 plus 3 plus I. So sum of all the current entering is equal to sum of current leaving. So I have only 4 ampere leaving the loop, so I can write this is equal to 4. So if you solve this you'll get I to be negative. So the negative sign is indicating that the direction of current that I have taken was wrong, so it should be going away, because you can see 2 plus 3 5 ampere is entering, so 5 ampere should go away, no, but I have considered this current was also entering, so that's why I got negative. You can try with the current going away from the loop. And this junction rule is based on the principle of conservation of charge. It says that whatever amount of charge is entering the junction, that amount of charge will leave the junction. Now let us talk about Kirchhoff's second rule, that is called junction rule and Kirchhoff's voltage law, KVL. So this law says that algebraic sum of EMF in any loop is equal to sum of product of current and resistors in that loop. So in mathematical form we can write summation of E. So sum of all the EMF is equal to sum of product of current and resistor, and this law is based on the conservation of energy. Now in order to use this rule we have to have sign convention. So to use this rule I have to consider one loop. So I'm considering the loop in this direction. So this is the direction, anti-clockwise direction, and all the EMF giving the current in the direction of loop is taken as positive, and all the EMF or cells giving the current in the direction opposite to the loop is taken as negative, and current flowing in the direction of loop is taken as positive, and current flowing in the direction opposite to the loop is taken as negative. And if you consider a cell, the cell always gives the current in the direction from positive to negative. If you consider this cell, the current will flow from positive to negative, and if you see this cell, the current will flow from positive to negative. Let us use KVL in this network. So as you can see, I have taken the loop that is DCFE D. So my loop is going anti-clockwise. Now in this loop I have to add all the EMF and all the product of current and resistance. So I'll start from C. So I have only one EMF, and this EMF is giving the current towards my left and the loop is going towards the right, so this EMF should be negative. So according to sign convention this is negative, so I don't have any other EMF, so I don't need to add other EMF. Now I have to see the product of resistance and current. So let's start from point C. So first resistance is R2 and current I2 is flowing, but if you can see my loop is going towards the right and current I2 is going towards the left, so this current is negative. So I'll just write minus I2 R2. So out here minus R2 I2, and now you take this resistance. Now I don't have any other resistance, so now I have R3. So in R3 I3 is flowing, so my loop is going towards the left, and I3, if you take this loop like this, so it is going towards the right, and I3 is going towards the right and loop is going towards the left, so they are in opposite direction, so current I3 is negative. So I'll just write minus I3 R3. So two resistors and one EMF, so I have used this rule. So let's take next loop, so that is CBAF C. So my loop is again anti-clockwise direction. So now I have two EMF, so I have to add. Now this loop is going towards the right and this EMF is also giving the current in the direction of loop, so this is positive. And out here also E2 is also giving current in the direction of loop, because if I rotate this loop, so the direction of loop is towards the left, and this E2 is also giving the current towards the left, so both of the EMF are positive. So E1 plus E2 is equal to, now I have to take all the resistance and current. So let's start from B. So I1 is flowing in the direction opposite to the loop, so I'll take this to be negative, and I'll go to another resistance. So in this resistance I2 is flowing, so my loop is going towards left and current I2 is also going towards the left, so this current is positive, so I'll just write plus I2 R2. So now let's use one more loop. So out here my loop is going in the direction anti-clockwise. So now let's see, so I have only one EMF in this loop, so now this EMF is giving the current in the direction of loop, so loop is going towards right, and this E1 will also give the current from positive to negative side, so E1 will give the current in the direction of loop, so it is positive. So positive E1. Now take the resistance and current. Now I'll start from here. So R1 is the current and I1 is the resistance and I1 is the current. So but this current is flowing in the direction opposite to the loop, so I'll take this to be negative. And now I have another resistance R3 and current I3 is flowing. So current is flowing towards the right and the loop is going towards the left, so this is negative. So EMF is positive and both the currents were negative, so E1 is equal to minus I1 R1 and minus I3 R3. Now we'll use Kirchhoff's rule to find the current flowing in this network, that is I1, I2 and I3. So as we have three variables, so we should get three equation using Kirchhoff's rule, and we'll solve this equation to get the current. So first thing, I'll take the loops. So these are my loops, two loops I'm taking. So first thing, I'll use Kirchhoff's current law, KCL. So I can see at this point P, so current I1 and I2 is entering, I3 is leaving, so I can write I1 plus I2 is equal to I3. Now I'll take this loop PR SP, and now I can see there is one EMF, and this EMF is giving the current in the direction of loop. So positive to negative, current is always positive to negative, and my loop is also in the same direction. So plus 5 is equal to, now I'll take this 20 ohm. In this 20 ohm current is going upward, so my loop is also going upward out here. So 20 I3 is positive, so 20 I3 is positive. Now I'll go to this 200 ohm, and in this 200 ohm also current I2 is flowing towards the left, and if you can see this loop also, if you take this loop out here, it will also flowing towards the left at the top. So this is also positive current, so I'll write I2 200. So I can solve this now. So I can write 20 I3 plus 200 I2 is equal to 5. So I've got the second equation also. Okay, so dividing both side by 5, so now this is the simplest form. So I've got two equation. Now I need one more equation, so I'll use this loop now. So PQRP. So PQRP, now I have one EMF. Now this, my loop is going towards the right and this is giving the current towards the left, so my 4 volt is negative. Now let's take the resistance. So I'll take this resistance first, so 60, and my loop is going upward and current I1 is flowing downward, so this current is negative, so this is minus I1 60. And I'll go to 20 ohm now. So my loop is going downward from the top, if you rotate this loop it will go downward, and the current is going upward, so this current is also negative, going in the direction opposite to the loop. So this will be minus I3 20. So minus I3, so I'll solve this again, make it simple. So if you divide both side by 5, write 5. By mistake I have written 4, so you can write 5. So if you divide both side by 5, so you will get 15I plus 5I3 is equal to 1. So if you write all the equation together, now you can solve. So it's up to you, so the way whichever way you want to solve, you can solve this equation. So to solve this, I can see this, if you have I3 in both 3 and 4, so I'll put the value of I3 in both the equation and I'll get I1 and I2 only, then I'll solve. So solving the equation is totally up to you, you can try your way also. So now I'm putting the values. So from equation number 2. So in this equation number 2 I'm putting the value of equation 3, so I'm getting this. So from equation 3, so if I put the value of I to be I1 plus I2, then you'll get this 20 I1 plus 5 I2 is equal to 1. So I'm writing the equation together. Now I can solve this two equations. So now if you can see, if you multiply this equation with 5, so you'll get 20 I1 out here. So now then I can cancel this. So I'm multiplying 4 with 5 and subtracting it with equation number 5. So this is 20 I1 plus 220 I2 is equal to 5. So if you multiply this with 5, you'll get 215 I2 is equal to 4. So I2 is equal to 4 by 215. So you got the value of I2. Now you can use any of the equation to get I1. So I'm putting the value of I2 in equation number 5. So you'll get 20 I1 plus 5 I2 is equal to 1. Then you put the value, then you'll get I1 to be 39 by 43 ampere, and this is 0.45. Now if you use the first equation, then you can put the value of I1 and I2 to get the I3. So I3 is I1 plus I2. So putting the values and you will get the answer. So this is how we use Kirchhoff's laws.